Hey, and welcome back to another video. Today we'll be going over a cracking the coding interview question. Now, I know it's been a while since I've posted, actually about 130 days, and I have a lot of things for you guys moving forward. Okay, so without further ado, let's get into it. And our question today is, there are three types of edits that can be performed on strings: insert a character, remove a character, or replace a character. Given two strings, write a function to check if there are one edit or zero edits away. All right, so what does this mean? Well, let's give an example real quick. We have two strings, tough and through. If we compare them, are they one edit or zero edits away? Now, given those two strings, through has two more letters, so it's already at least two edits away because we have to insert two more characters. But I'll get more into that. Let's get to it. Okay, when you're given a problem, usually the interviewer will give you some inputs and the expected outputs. And then that's to give you some clarification and understanding of what they're asking. But you're not always going to understand just from a couple examples. And so what I would recommend doing is asking them to either clarify or give them some examples and what you think are the expected outputs. Because you can't solve a problem if you don't even understand what it's asking in the first place. So in this problem, you're given two strings, and we want to make sure that they're only one edit away. Okay, so the first string should only be one edit away, whether it's replacing a character, inserting a character, or removing a character to equal the second string. And if it's more than one edit away, our function that we're going to create needs to return false. Otherwise, it returns true if it's 0 or 1 edit away. So I'm going to pretend that I don't quite understand what they're asking, and I'm going to give the interviewer some other inputs and what I expect the outputs to be. So let's go through this. So what I would say is, if I just remove one P from the first apple, these would be equal to each other. That's only one edit, and that should return true. In the second example, we have male and tail. If I replace the M with the T, then both of these words are equal to each other. That should return true because it only required one edit. Then we have male and fair. I would have to replace the M with an F and an L with an R for them to be equal to each other. But that's more than one edit. It's actually two edits, so that should return false. And then finally, just to kind of make sure, have like a control statement, we say bay and bay, which is spelled the exact same way. This should return true because there are zero edits away from each other. Then the interviewer would confirm, and you say, okay, now I have an understanding of what you're asking. Now I can go through some solutions to see how it would solve this when I write the function. Okay, so my first solution that I would typically show them is the brute force way, okay, or the headstrong. It's not necessarily the best way to do it, but I'm going to get right into it, and I know it can be solved this way. So in this case, we have two examples, apple and apple. These are the two strings we're checking to see if the first string is one or more edits away, so it equals the second one. Well, just by looking at it, I know that I can just remove this P. That's one edit, and it equals the other one. However, we have to code this and write a function at some point, so we have to go through how we would do that. Well, we would check each letter one at a time. A and A is equal to each other. P and this P are equal to each other. And then we have a P and an L. The third letter in each of these words not equal to each other. So we could do a replacement, I could show an assertion, and I could do a removal, and I could branch off from there and then check each of those ways to see if I can get them equal to the next one. And I would do that for each character. So if I replace the P with an L, so if I just replace that with an L, now the third letter in each word are equal to each other, L and an L. That was one replacement. Now we have an L and an E not equal to each other, so I could do a replacement, or I could remove it. Now I know this E is equal to that E. However, that was two edits. We did a replacement and we removed something. Okay, so we could do all of the edits for each character that aren't equal to each other and go that direction, right? It's not very efficient, and typically you'd have to couple for loops, so you'd have like a nested for loop. Well, we know that nested for loops are big O of n squared, especially when you're dealing with strings and you have to go through the length of a string. Okay, that's big O of n squared. It's not very efficient. It's not a good algorithm. There's got to be a better way for this. Okay, before we get into a better algorithm or better solution, let's make sure we understand exactly what it's asking. Okay, and sometimes it's okay to take a step back. You just went through the brute force method or some other solution, but you know that you can do better. All right, so let's take a step back. What exactly does replacing a character mean? Well, in this example, we have male and tail. Our code would iterate through each letter in these words, and we would say, okay, male and tail do not equal each other. We'd have to replace one of those to equal the other. We don't care what the letter is. We just know that they're not equal to each other, and we're going to keep a counter of how many we had to replace, or some method of making sure that if it's more than one edit, we return false. Well, for insertion, because we have apple and apple, the first one is missing one of the p's. Well, we know we'd have to insert a p here for them to be equal to each other. So we just have to insert a letter into the first word, and that's how it equals the second one. And that's exactly how we know it's one insertion away. They're the same except for one letter. Now, we could use the same example. However, we say the longer word is the first one and the shorter word is the second one. So this is for removal. We know that if we just remove one letter, it's going to equal the second one. So that's how removal works. Okay. Now, based on this knowledge, okay, we can come up with a better solution now. Okay, now that we have a better understanding of what we have to do for the problem, we can do better than the brute force solution by going through each letter, checking every replacement, insertion, and removal to see if it equals the second string. We don't have to do all that, okay? Remember, we're only checking to see if the first string is one edit away from the second string. So let's think about that. If the first string differs in length by more than one of the second string, we automatically know that this is going to return false and it's not going to work. Okay, for instance, if we added a B in front of the first one to be Bapple, that has 6 letters, the second string only has 4 letters. Well, 6 minus 4 is 2. We're going to have to at least remove 2 letters from the first string to even equal the length of the second string. That's 2 edits, 2 removals. That's more than one, so it's already not going to work, right? So we don't even have to do anything at that point. We just return false. However, if the first string's length, so it's 5, is greater than the second string length, which is 4, that means we're doing a removal. Okay, so in order to get 5 into 4, we just remove one letter from the first string to equal the second string, just like that. So then apple, APLE, would equal APLE on the second one. Okay, that would mean it's at least one edit away. We would still have to check the letters individually, but if they don't match up, then that's at least 2 edits, and we just return false. However, if the second string's length is less than the first string's length, then this is insertion, okay? So, for instance, if we just had ALE and then APLE, well, ALE is 3 letters, the second string is 4 letters. We have to insert at least one letter into the first string to make them equal in length. And then we can check the characters. And if each of those characters or letters in this word aren't equal, that's another edit that would be replacing something. And that's more than one edit away. We just return false. Okay. And in the case that they're equal in length, all we're going to have to do is just do a replacement if they're not equal to each other. So we go letter by letter. We might have to replace one to make them equal. But if we have to replace more than one, then we know that we can't do this and we just return false. All right. So now this means that all we have to do is have a single loop depending on what the action is we're doing. All right, let's go over just a couple examples of how we actually implement this in the code, and then I'll actually show you the code in precisely how it's implemented. So we have 2 strings here, right? We have the first string and the second string, male and tail. These are the 2 strings we're comparing. First off, we know that they're the same length, so all we have to worry about is replacing letters. we don't have to worry about inserting them or removing them because they're the same length. Now, what I would do is I would have some Boolean variable and set to false initially, or you could have a counter, and every time you find a difference in each of the letters as you're comparing them, you can just increment it by one. And at the end, if you have a counter that's more than one, then you just return false for everything because that means it's more than one edit away. All right. So what I would do is just have a for loop, okay, going through each of the strings, each character or letter at a time. So the first time through, we would check the first letter of each string. Well, we have M and T. Obviously, these are not the same. Okay. So what I would do is then say if these are not equal to each other, if this Boolean variable is set to true, then you want to return false. Otherwise, found difference is equal to true. Okay, so initially, when we go through that, this is set to false. So it can't be equal to true the first time through, right? So then we cross this out and set this to true. Okay, now we go to the second letter, A and A. They do equal each other, so we don't do anything. I and I equal each other. We don't do anything. L and L equal each other. We don't do anything again. But let's say this was a D for made and tail. Well, we would see the D and the L, they do differ. So if the characters on this iteration of the for loop don't equal each other, we would say if found difference is equal to true, which it is because we already found a difference. Now this means we found a second one. Well, then we just return false, and that means this is more than one edit away. Now, insertion and removal can use the same algorithm, all right? It just depends if you have the shorter word first or the longer word first. Okay, so if the longer word is first, then we have to remove, like we said. If the shorter word is first, then we have to do an insertion. Okay, but it's really the same principle and algorithm as replacement, sort of. So what we would do here is go through the same thing, except you just don't need a Boolean variable. You could have a counter for string one and string two. All you really need is like a counter for each string. All right, so let's just go through this. So we have another for loop, or you can have a while loop, and go through the first iteration, A and A, they're equal to each other. P and P, they're equal to each other. And then we have P and L, not equal to each other. So then what we would do is if these are not equal to each other, now we just want to move the first string. We want it to advance one letter and then keep the second string at that same letter. Okay, because remember, this is a removal. So we just want to check the next one now. Now, does the L equal the L? It does. And then does the E equal the E? It does. Okay, and this was only one edit away. So we just returned true. However, at some point we had to advance again. We kind of have like counters in the background checking this. If we had to advance again, well, we know that's two edits, and that's more than one edit, we would just return false. Now, in our better solution, since we're only worrying about basically executing one method, whether it's going to be a replacement, an insertion, or a removal, depending on the sizes of the strings, we're only be worrying about one for loop or a while loop, and that's just based on the size of the string. So this is going to be big O of n, which is much better than the brute force way, which is big O of n squared. Okay, here we are. Here is the code. I'm going to briefly go over this since we kind of already have an understanding of how it's going to work anyways. So with the better solution, we have a method here that we take in both of the words or strings, whatever it is. We take the first and the second one. We first check to see if both of them are the same length. So first.length equals second.length. If they are, then we only have to do a replacement. We have to check if we're replacing any letters to equal the other one. Right. However, if the first length is shorter, so we have to add one to its length to equal the second one, then we have the same method, check, edit, insertion, or removal. All right, then we pass in the shorter word, which is the first string, pass that in first. Then if first.length minus one, so if the first string now is longer than the second one, and we were to subtract one from it, so if the length, like for instance, we have the apple and apple, where the first apple has the two P's, right? That's 5 letters. If we remove one, then it has 4 letters. Well, the second apple, which only has one P, has four letters as well. So if now that's equal to each other, then we have the same method. However, we pass in the shorter word first. Okay, so basically, in each of these, we're using the same method. We're just passing in the shorter word first. All right, so for the replacement, uh, we have the two strings that we pass in. We have the Boolean found difference initially set to false. All right, now this is why it's big O of n, because if we do this, we have this one for loop here where it's based on the size or the length of the string, and that's it. Okay, so that's why it's big O of n. So we iterate over, since they're both the same length, first and second, we just iterate over one of them. So you can say first.length. Then we check at each letter in the word if they're equal to each other. If they're not equal, so at the character at I, so initially 0, so that the first letter in each of the words are not equal to each other, we say if found difference equals true, then we just return false. Okay, so if found difference is true, that means there's going to be more than one edit or more than one replacement. All right, so the first time the first time we find a difference, found difference is not true. It's, remember, up here it's set to false. Well, then after that, after the if statement, we then set it to true. So the next time we go into the for loop and any uh, iteration that's going to be coming, any of the next iterations, if any of the characters do not equal each other in the strings, we're going to come to here and say if found difference equals true, which it will, then we return false. Okay. However, if we find no edits or only one edit, we'll just come down here and return true. And then finally, we have the check, insertion, or removal. So the first string that's passed in is always the shorter one. And then we have two variables, index1 and index2. They're set to 0. These are going to be where or what character or what letter we're checking in those strings. So index1, we start at 0. That means we're checking the first letter. Index2 starts at 0, meaning we're checking the first letter of the second string. Okay, we just have a while loop saying while index2 is less than second.length and index1 is less than first.length. All right, so again, it's just big O of n for this algorithm, okay, because the while loop is just based on the length of the string. Now, if the character at index 1 does not equal the character at index 2 for each of the strings, what we do to kind of our statement where this could be false, where we would return false. If index 1 does not equal index 2, that means somewhere along the line, uh, we had to make 2 edits. All right. After index 1 does not equal index 2, if there is an edit, so they're not equal to each other, we'll never get through this the first time through, okay? All we do is increment the index of the second string, the second one or the longer word that's passed in. So we have the first word, all right, we stay at the same letter, but on the second word, because it wasn't the same, we move it over to the next letter, all right? And then we come back in the while loop and we'll compare those letters, all right? And then if there's another time where the letters don't compare, that means we're about to do our second edit. If index 1 does not equal index 2, which at this point it wouldn't, we just return false. Okay. However, if at any point the characters in the strings do equal each other, all we do is just increment index 1 and index 2. Okay, we increment them both because I want to check the next characters or letters in the word. Otherwise, we'll come all the way through the while loop, through all the letters in each word, and then just return true.